Images, the ultimate system for graphic design. It's taken years of software development to make the Images digital paint system a totally new dimension in artistic expression and creative control. It's incredibly sophisticated, but so easy for an artist to use. Take the electronic pen in your hand. The system responds instantly. You pick a brush by moving it over the list of options located on the menu display. There are dots of every size that make lines of every width. And clusters, and stars. Better yet, make your own brush from any part of a picture. With picture paint, you can actually paint with a full color image. And a special variation of this, called Z-Paint, amazingly integrates corresponding parts of each successive shape. Imagine the possibilities. Naturally, you can magnify portions of the picture for exacting detail. Yet another feature lets you blend the paint for softer effects. Images with 16 million possible colors. You create your own palette from the color maker. By controlling the saturation, hue, and intensity, or the red, green, and blue, you compose the eye. Drawing pad and not a paint box. The Images computer is equipped with some remarkable drafting aids. Lines. Splines. Circles. Ellipses. Folding. And mirroring. and you can scan any image into the system through a camera and go from there. Then, if you need to add print, the Standard Images computer comes with 20 regular fonts and a character generator, proportional spacing, automatic centering and sequencing, and options for many more. And when your painting is done, you store it permanently on disk for recall at any time. In fact, you can even store the whole process of your creation with a history feature. Images. Amazingly responsive, infinitely versatile, elegant.
Bebop is a three-dimensional animation system created by Garland Stern at New York Institute of Technology. The system allows creation and preview of animated 3D figures displayed in skeleton line drawing form. An animator using the system can step through the joints of an articulated figure on the computer display. The brightly outlined section of the figure is under real-time control and can be rotated or moved about. The animator may input data through the keyboard, or, more frequently, use a joystick to control the figure or model in real time. The joystick permits the operator smooth control of position and orientation in space. The keyboard permits finished frames to be numbered and saved in computer memory. These frames are not merely drawings, but complete three-dimensional specifications of sets and characters, sculpted out of geometric coordinates. Once the key frames have been designated and saved, the computer can then generate a smooth sequence of three-dimensional motion from a few key frames specified by the animator, then regenerate the sequence later with full color and shading. The tween animation system, developed by Ed Catmull at New York Institute of Technology, is a two-dimensional computer animation system based on interpolation of animators' drawings. The system takes drawings as input and transforms from one to another, thus generating animated cartoons. The process begins with a drawing traced into computer memory. The order and direction in which each line is drawn is important to the final result. Each sequence is planned in advance. Keyframes are drawn on precisely registered sheets of paper. The paper is placed on a digitizing tablet, where drawings are traced into the computer. Sequence names and commands are input by keyboard. Tracing the drawings, although a meticulous process, is very simple compared to the laborious methods of traditional animation. In the traditional method, each keyframe is drawn by an animator, then checked and polished by an animation assistant. The frames between the keys are drawn by in-betweeners. Then, each frame is transferred to acetate, where it is hand-painted superimposed on a painted background, and photographed. In the tween system, once a drawing is entered in the computer, it need never be drawn again. All manipulations, in-betweening, inking, and painting are assisted or performed automatically by the computer. The screen displays the drawing as it is traced on the digitizing tablet, where a matrix of wires senses the location of the artist's stylus and converts each line into a stream of XY coordinates. Once a sequence has been entered, it may be played back at any speed. This real-time preview of the animation is a valuable feature of the computer animation process. Here, the position of the pen, indicated by the tiny triangle at the top of the green screen, controls the animation. By moving the pen across the tablet, the animator may view the frames of the sequence at any speed, forward or backward, stopping to examine any frame. When the outline version is judged satisfactory, the computer is used to render and record the sequence in full color.
It had the face of a donkey and the tail of a cat. It had the hair of a monkey and the wings of a bat. And it ranted and it raved and it babbled like a brook.
What was it?
A donkey, a monkey, a gopher, a sofa, a seal, a wheel, an eel, a meal, an ox, a box, a fox, a lox, 2 socks, 4 rocks, an engine that knocks, a toad, a road, a whale, a nail, an easel, a weasel, a duck, a buck, a minx, a sphinx, a lynx, a winx, a rose with thorns, a spider with corns, an ape and a callus, a grape and a palace, a shaper, some paper, a moose, a goose, a bat, a rat, a hat, a cat, even that.
Spread the super flavor of lifesavers. Spread the super flavor around. Spread the super flavor of lifesavers.
Cherry, super orange, peppermint, lemon, strawberry, peanut butter, rum, Christmas, fancy fruit, cherry, orange, peppermint, lemon, strawberry, butter, rum, savers.
Spread the super flavors
All around.
lifesavers.
I see a 3.
I see a 3.
I see a 3.